All right, so I'll get started with this. So today's material, a lot of what we do is good review for the exam if you haven't taken the exam yet. But we'll be using that to introduce a new idea. But at least half to 3/4 of what we do today is stuff we've done before. Okay, so let's see how you do. So this graph shows f of t, which is the distance traveled by a rocket in meters, t seconds after launch. Okay, so you're going to start by, first question is, make sure you know what the input quantity is and what the output quantity is of f, of the function f. And then once you got that, then you can start with these questions. So you're using function notation. I'm not asking you to estimate any values off the graph. That's not what this is about. This is about using function notation. To represent this quantity, the change in distance, and to represent the average speed. Okay? So I'm just going to let you loose here while I do attendance. Work on this, think about this, talk to each other, compare what you got. Is the setup and the questions clear? Is there need any clarifying with that? Okay, so find a partner. You can consult with Megan, check your work with her. But everybody, minds are on, right? Minds are on. Oops. Questions are definitely turning for your exam. Gotta know what it is. Okay, that one's right. What was average speed? Yeah, average speed. Doesn't play on the exam. Average speed. Okay, so I saw lots of people got the first one right. Good. So how about this side? Justin, did you get 1A? How can you use the function notation to represent this change in distance? So if it's a change in distance, in general, what operation is that going to be?
I'm just having trouble with the function notation.
Okay, so how do we calculate a change?
Oh, y final minus y.
Right. So it's going to be the final value of distance minus the initial value of distance. So the final value of distance is going to be how far we've gone at 2 seconds. So how can you use the function notation to say what the distance will be at 2 seconds? F of 2. That's how far. That's the distance traveled by the rocket at 2 seconds. And what's the initial distance? See, you know how to do it. Change in, so it's final distance minus initial distance. So f of 2 minus f of 0.5. And so now I want average speed. Brian. And so that's the change in distance. Change in distance over the change in time. If you wanted, you could simplify that denominator. It would be 1.5 seconds, right? So this is our average speed, the change in distance over the change in time. And what was our meaning for average speed? What was our meaning for average speed? Got to know this. Omar.
The average speed is the constant speed needed in order to cover the same amount of distance in the same amount of time.
Got it, right? So we had this, the reason that I put this on your quiz was so you'd memorize it and never forget it. Constant speed, average speed is the constant speed to cover the same amount of distance in the same amount of time. So coming over here to the graph, if I had this point for the starting time 0.5, ending time 2. So that we can highlight 2 points on the graph. Right, we can highlight 2 points on the graph. And so we have the corresponding change in distance. Whatever, I'm just kind of eyeballing that. So here's our change in distance from here to here, right? As the time changed from 0.5 to 2. And so how is that average speed? How could we represent that average speed on the graph? How could we represent that average speed on the graph? Audie?
Create a straight line from the 2 points.
All right. So, yeah, so this is the straight, and what about that value? What about that line relates to this value, right? This is just a number, right? That's just a number. And so how does that number relate to the line?
That's the slope.
He says it's the slope of the line. What do you guys think? So our change was 1.5, right? And we're starting at 0.5? Okay? So again, what about that line? What about that line is our average speed? What about that line is the average speed? Shola. Okay, so this ratio right here, the average speed, that's a number, right? That is a number. What does this line have to do with that number?
Well, that's the constant speed that someone else would have to travel to meet the average speed.
Okay, it's the constant speed someone else would have to travel, or another rocket would have to go to do what?
To reach the exact same distance in the same amount of time.
To cover the same change in distance in the same amount of time. So that red line then is kind of showing the time-distance relationship of this other rocket, right? It's this time-distance relationship of this other rocket, which would achieve the same change in distance over the same change in time. And this line, what about that number relates to this line? Change in distance over change in time? It's a slope, that's right. Yeah, I already said that. I didn't say it was wrong. Just want to hear someone say it again. Right, so the change in distance over the change in time is the slope of that line, the constant speed to go the same distance in the same amount of time. Okay, so how would we find that number? So now I want to get that number. What would it take to get that number exactly? What would it take? What's that? Tell me more. Math, Jaden.
Plug in those numbers into the function. No, I lied. I'm just kidding, because there's no function there.
No, it was right.
Was that right?
Yeah, sure.
But there's no function.
You just don't have the rule, right? So there is a function, right? There's a function, f, okay, that is this distance time profile for the rocket. So, what would you do?
You would plug in the numbers, see if we
Yeah.
time distance relationship.
Yeah, we would get this distance at 2 using the rule for f, and get the distance after 0.5 seconds using the rule for f, and we'd solve. Okay, so let's do that. So I should have done this before. Anyway, that's fine. Okay, so yeah, I'll do that. All right, so f of 2 minus f of 0.5 all over 1.5. 59.6. What's the units on that? 59.6 what? What is it? Meters per second. Tell the person next to you what that number means. 59.6 meters per second. Tell the person next to you what the meaning of that number is. Go. What does it mean? 59.6 meters per second. Oops. Okay. Jared, what's 59.6 meters per second? No, I'm sorry, this is first in front.
It's the constant speed of the rocket, so it's going to travel at 10.6 meters every second. Or the average speed that we must travel.
Okay, so does the rocket go 59.6 meters every second? Does the rocket?
The average speed of the rocket that travels.
It's an average speed of another rocket.
Constant speed needed to travel.
Yeah, no, it is the average speed of our rocket, of the actual rocket, which is 59.6. Put it all together. You can do it. I know you can do it. Yeah. So it's the average speed of our rocket, which is
The constant speed needed to travel the same distance in that time.
perfect. Good. Good job. All right. Any questions on this so far? All right. So let's advance it here. 2 and 3. Work on these questions. All good practice for the exam. Read carefully. Understand the meaning of what's being asked. You really got to read carefully and think about this. To get this, we have struggled in the first class on this. Just do A first. Raise A right first. Change this.
Oh yeah.
So the distance that I think started together once changing signs. So during changing distance.
What is that? Read it. So you're saying what? That's what you did. No, B is not correct. Oh no, I'm sorry. Neither A or B are correct. Don't need to erase anything. You need to change. So in A, you didn't put change in this. You just put the final value of the text. There you go. Good. No, so you got the negative numerator right. The time right. So what is the change in time? What is the change in time? Yeah. Sure.
So average speed is the one that's going to change the distance by changing time.
Sure.
Okay, so that's pretty good. But the constant speed was it's the same with the speed. Is it or is it just defined?
First of all, the rocket is not traveling at a constant speed. But an average speed is a constant speed. It's a constant speed of another rocket to cover the same distance in the same time as our rocket. Is it better? Yeah. Okay, let's see. Brooke, how did it go? So I want the change in distance. So let's take this one step at a time. What's the initial time? What's the starting time? Starting time, 1. And what's the final time? H, is it H or H plus 1? The final time. H plus 1. It's not H. H is the duration. It's telling you that H is how long this time interval lasts, right? Starting at 1 and lasting 8 seconds. So it's like we're starting here at 1 second down here, right? And so we have some interval of time that is H. I could have made that line short. I could have made it long. I could make it any length because it's variable. And so therefore, if we start at 1 and it lasts H seconds, what's our final value of the time? Is it H? It's right. It's H plus 1. Oops. So we're starting at 1. And we end up at H plus 1. So therefore the change in distance is, Brooke? F of H plus 1 minus F of 1. What do you think? Good. Okay, average speed for that same time interval. Joe, did you get the average speed?
Is F H plus 1 minus F1
Good.
over H.
H. So could we put H plus 1 minus 1? Final time minus initial time? Sure, we could do that. So we can take the final time, right? Minus the initial time. Or we just think about it. So this is calculating the change in time. What change in time is it? Just H, right? Because and that's what this comes out to be. H plus 1 minus 1 just turns out to be H, which we knew from the beginning. That was the change in time. Okay, so what we're saying here is we're fixing the starting point at 1, but now we're letting that change in time be variable. See? So for a greater H, we get a greater average speed. And if we reduce H, make it smaller, we get this other average speed, right? So we're saying H can be any length of time starting at time equals 1. So depending on what H is, you get a resulting average speed, okay? What about now starting any time X and lasting H seconds? So now not only we're going to let that change in time vary, but we're going to let the starting time vary. And let that be any value X. So Aaron, did you get that?
F of H plus X minus F of X.
Say it again.
F of H plus X
Okay.
minus F of X.
And that's the change in distance. He's saying that's the change in distance for starting at time X and lasting H seconds. Agree? Cool. All right. And then how about the average speed?
F of H plus X minus F of X
Change in distance divided by?
over H plus X minus X.
Okay. Change in time and What is that change in time? H. Can I fit it? Maybe. Is it still on the screen? Okay, so now not only am I varying H, but I can vary my starting time. So that starting time is X. So here I'm choosing X to be, say, 1.5. And then H can be varied. And what will that whole ratio calculate about the line? What is it? Hamid. What does that ratio calculate about this line, starting at X and lasting H?
The average speed.
Average speed. And what about the line? So what about the line represents that average speed?
The constant speed that is needed to cover the same distance and the same amount of time.
Okay, true. That's what the average speed is. But Fuda, what about this? What does that number that we get for that ratio? How does it relate to this line? What about this line? It's the slope of the line, right? The slope of the line, or how much the distance changes for a change in time. Okay, this is a special thing in calculus. It's very important in calculus. It's called this thing, which is the change in output over the change in input, is called the difference quotient. Difference because both those changes are calculated by differences, right? And then you put those into a quotient. So when you see difference quotient, this is what we mean by the difference quotient. And when we have distance and time as our two quantities, when we have distance and time as our two quantities, what type of value does the difference quotient calculate? When we have distance and time, what is it?
Average speed.
Average speed, right? So that will give us average speed. When distance is your y coordinate, your y quantity, time is your x quantity, that difference quotient will give average speed. Okay, any questions? All right, so now I'm going to give you the function, okay? Sorry. Okay, just leave it like that. All right. So I'm going to give you this function. F of t is 23.84 t squared. So practicing what we did last time in class, I want you to first write out the set of instructions on the input that this function is, there's that word again, mandating, I guess. It's the only word I can think of. Right? Write out the set of instructions on input that this function is, what's the word? This function is telling you to do. That's what I should do first. So given an input, what is that rule telling you to do with the input? And then, once you've got that, then we're going to rewrite the difference quotient in terms of this rule. Okay, so what is our difference quotient again? F of x plus h minus f of x all over h. Okay, so write out the set of instructions. That's part A. Once you have the set of instructions on input, like in words, right? First, you take the input and you do this. Then you take that and you do this, right? So this function is telling you to do something to the input. Write out that set of instructions. And then Using that set of instructions, you're going to rewrite the difference quotient using incorporating the rule, okay? Incorporating those instructions that you wrote out in part A. See if you can do it. If you're stuck, ask one of us, ask someone around you, okay? Performs. Got it. The set of instructions on the input of this function performs. It performs a set of instructions, okay? It does something.
Hooray.
What?
Hooray. Hooray.
Hooray. Hooray. You're stuck. Get help. Where'd they go? What does this function tell you to do with the input?
Well, back to what? Square root.
What the wording of what? How about part A? So what does the function tell you to do with the input? So in that, how about in that sort of thing that I put a box around? What is the input? What is the input? T. So it's telling that thing on the right side tells you to do what to T? Square it first, and then multiply by 23.84. That's what that function does. It takes the input and squares it, and multiplies by 23.84. So now, down here, here's the difference quotient. What's the new input here? F of x plus h. What's the input? X plus h. So what do we say? This function does what's the input first? First you do what? Square it. You take x plus h, you do what first? Square it. And then multiply by 23.84. So that would be f of x plus h. And then minus f of x. Same thing. We're going to do the same set of instructions to now a new input, which is x. You can rewrite that fraction using the function. How it tells you to act on the input. So, Aaron, you were talking about the wording. What wording was confusing? Yeah, you better now? So the rule is the set of instructions, right? Yeah, that's first. Okay, so read, so we're just looking at the f of x plus h. What's the input? F of x plus h. Now, take x plus h. Follow, yeah. Right, because x plus h is the input, so follow the instructions on x plus h. But that's just that first part of it, right? And you have minus f of x, same thing, and then over h. So, square the input, and multiply the result by 20. Perfect. Okay. So now, to get to here, we're going to rewrite this whole thing. So first we look at this. What's the input? And what set of instructions did you just write out? You do what you wrote out here with x plus h. That set of instructions now is acting on x plus h instead of t. Yes?
But I have a question though. We only have one result. We don't have a final so it is trying to difference.
No, this is the difference quotient right here. This is it. This is the difference quotient.
So that's the answer for D.
No, you're going to rewrite this using your set of instructions, using the rule.
Okay.
So you got to rewrite this, and you got to rewrite this, and it'll be equal to this, as long as you follow what you did in part A with the input each time.
I mean that's what I got the same answer as you, but the only thing I don't understand is like that's just finding out the speed.
Yeah.
Okay. So
I'm telling you now in part B, so when you look at this right here, when you look at that right there, do it now. Do this set of instructions. What did you say? You said square the input, right?
Yeah, square the input.
And then
And then
times the result
by
by 23.84. Okay, so now do it. Here we go.
Doing.
Do it. What does the function tell you to do to x plus h? This one down here? Yeah, so h is just h. This is not invoking the function, right? This has nothing to do with the function. It's just our change in time. Okay, Walter, did you get f of x plus h? What was f of x plus h? Tell me. Yep. What was it? X plus h squared. What do you think?
I think yes.
That's what f of x plus h is, okay? What about f of x?
Same from x squared.
So tell me, what is it?
That'll be 23.84 parentheses x.
Right, so in both cases, what do? We took the input and squared it, multiply the result by 23.84. And then, all over,
Divide by difference which is
h. Okay, so now those who love algebra, you know, your moment has come, okay? Your time has come. So we're going to expand this out and see if we can simplify this. Okay, x plus h quantity squared. X, is it x squared plus h squared? You all should have had in previous course. There's a middle term, right? There's an xh there, an xh there. So plus 2xh. Keep going, Christina.
Plus h squared.
Okay. All over h. Okay, I'm going to bring it up here now. Okay, so we can now, all we're going to do is just distribute the 23.84. And I think we get, is it 47.68? How did I do? Check my math. Agree with my math? Okay, what can happen in the top now? So there's something we can do. What is it? Yeah, so we got plus this term and minus this term. So those become 0. That minus that is 0. So we're left with these two terms right here. Notice these two terms both have h in them. And so we can factor out, they have at least one h, right? So we can factor out h. So h times 68x plus 23.84h. And that's all over h. And the reason we factor that h out is those h over h is 1. H over h is 1, so it goes away. And we have this new expression, which is simpler expression, 47.68x plus 23.84h. What does it mean? That would calculate a number, right? If we had a starting value of x and a time span of h, we would get a value. That expression would give us a value. It's a quantity. What does it mean? It's the meaning of the quantity. Tim, what would the meaning of that value be if we plugged in a starting time of x and a time change of h? Into that, we got a number. What would it mean? What's that?
Distance would be the original thing where you're going to do the y value.
It'd be the y value. What do we think? Hamid?
The average speed.
Average speed. So we got y value, average speed. What do you think? Yeah, because so we've made a chain of equality, right? Everything we've done in this algebra, everything's been equal to the thing before. So really, it's all equal to this. That's what I did in blue, which is average speed, right? Average speed. So this is now this is like a simpler way, given a starting time x and a change in time h. It's kind of a fast track. It's a simpler way to crank out what that average speed would be over those h seconds. Does it make sense? Any questions on the algebra? You've got some algebra to do over the weekend, like this. So we'll make sure we'll do another one at the end. Okay, so let's just test this with that very first example we did. It was starting at time 0.5, right? And lasting how long? It was from 0.5 to 2. So therefore, x would be what? 0.5, and what would h be? 2? Is h 2? No, it's the change, right? It's that change, so 1.5. So put in 0.5 and 1.5, and what do we expect to get? We expect to get, what? This same number right here. Do it. See if you get it. So if you put in 0.5 and 1.5, we should get the same 59.6 for the average speed. Did it work? 47.68 times 0.5 plus 23.84 times 1.5. There it is. So it's still average speed, just in a different form without the quotient anymore. Can I erase what I've written? Can I swipe that? Okay. So, new example. Oh, wow. Oh, no, we got time. All right, cool. Cost. So here's a different function. The input of this function is the number of units that a manufacturing company produces. So let's call it, besides units, let's call it something else. Number of, what are we producing here? That's not going to really work with this. So, I don't know, cell phones. Okay. All right, so say this is number of cell phones produced, and this is the total cost to produce X cell phones, okay, is the output. And that's given by C of X. C of X. So what I want you to do is, a couple things I want you to do. First, set up the difference quotient. If the number of units produced increases from 100 to 800 units. And then try to make sense of what number that would calculate. What would the meaning of the number that difference quotient calculates? What would it mean? Okay, so set it up. And then see if talk out part B. Right? Who uses cell phones anymore? Smartphones, right? I use a cell phone. Okay, compare with the person next to you. Have a conversation. That sounds like 2 or 3 conversations. Talk to somebody, everybody. Okay, Jonathan, you're up. Tell me about the difference quotient for an increase of phones produced from 100 to 800. Did you get that? What's that? So if we want the difference quotient for starting at 100 phones produced and up to 800 phones produced, can you set up the difference quotient using C of X? Is it? Not sure? It's okay. Anna, did you get it?
I could see 100 plus 800
Okay.
minus C of 100 all over 800.
All over.
Or
Okay.
it would be 700.
So the question you're asking is, what's the starting number of units or smartphones? What's the starting number of smartphones? And what's the final number of smartphones? So do you want to change this?
Yeah. To 700.
So what is in this right here? What should this be? What is it? No, it's just the final value of number of smartphones. Yeah, so we could have written it as 100 plus 700, but it's just 800. And then what's the change in the number of 700? Yeah. Well, that's what you should have gotten. That's the difference quotient for this particular case. All right, so that produces a number. I'm going to do it. Ready? Here we go. So C of, C of 800 minus C of 100 all over 6.79. So let's first of all, what would the units be on that number? So that if we calculated that, we get 6.79. What would the units be? 6.79 what? Dollars. Dollars per smartphone. Right, because the numerator is the change in amount of dollars, and the denominator is smartphones, right? So change in dollars over change in smartphones. So therefore that unit has to be dollars per smartphone. Okay, so what does that mean? What does that number mean? $6.79 per smartphone is what? Is what? Alex?
Well, for one, we're getting ripped off. That's
Exactly.
And that's just how much you would have to. Like, that's a constant cost or money you have to invest making smartphones in order for you to like end up making the same amount of units with the money as the other one. I don't think that made sense, but I know in my head it's kind of working.
Okay. So yeah, so we need to improve, tighten that up a little bit. So anyone else want to give a chance? Nina.
I would say it's the average change in the cost to produce smartphones from 100 and units produced changes from 100 to 800.
Average change in the cost.
Average change in the cost per smartphone produced.
Okay. All right. So yeah, it's the average rate of change of cost, or it's the amount of money, the cost per smartphone, such that what? So from 100 to 700, did it cost this company $6.79 per smartphone to produce the smartphones, starting at 100 to 800? Is that what happened? Is that no? So instead, what happened? Right. At first, how much was it costing the company over here? More or less than $6.79 per phone? Less than. Is it less than over here? Nadine, what do you think? The same? So over here, it costs $6.79 per phone. Be less than $6.79. Patrick, what do you think?
I think it would be more,
Why?
because the graph itself is much steeper on the left than it is on the right. So one increase would be a lot bigger of a change.
Right. Okay. Over there versus over here, right? So pretend that's making one more phone. Delta X equals one more phone, right? Delta X is one more phone. What was the cost of that phone versus the cost of this one? Which one was greater? The one on the left. This phone cost the company more to make than this one over here. Say the 750th phone cost less than the 150th phone that they made. That's just the way it works. When they work, just in a general sense, when you make lots and lots, it costs less per unit the more you make. Okay. So therefore, but this is just one amount per phone from 100 to 800. So what does that number mean? So they cost more here, and then each phone costs less and less to make as we make more of them. So what is this number, 679? Fuda.
The average?
Yeah, so that's the average cost per phone, right? The average cost per phone over those 700 units of phones made. Okay, and that 6.79 could be shown by the slope of the line through those 2 points. No, it's terrible, but it's supposed to be here and here. I'll try one more time. That's much better. So the slope of that second line. Okay, so the slope of that black line is 679, meaning every phone you make costs the company $6.79. And yes, if that were real, and that might not be far from the truth. Okay, they make a lot of money selling these phones, right? Okay, moving on. So for X units produced, find the average cost per unit for producing the next H units. So I want you to write an expression. Starting at X units produced that finds the average cost per unit for producing the next H units. Go. So now I want to start at any number of units. Say right there. And end at some other over here. This is what we're talking about. So we're going to start at some number of units produced. We're going to have some increase in the number of units, and we're going to have an ending number of units, or smartphones. Who have we not heard from yet? How about Morgan? Did you get this? Okay, give it a shot. This is what she's offered up. Austin, you like it? Tim, what do you think? Okay, so what should the bottom represent? So what is the meaning of the bottom? Tim, what is the meaning of the book? Not what variables, but what should the bottom be, meaning-wise?
The time difference.
Yeah, so if you're thinking time down here, it's not time anymore, right? So it's number of smartphones. So you're right, it's the change in smartphones. So is it H? We're starting at X and we're producing H more, right? You put X.
Because if you look at the graph, you marked it as delta X, which is the change.
It's the change.
So what if you do C of X plus H minus C of H, giving you a delta of X,
Okay, so we got to really know
delta X?
what is the starting, reading this here, what's the starting number of units? What's the starting number of units? How many do we start with?
X.
X, right? That's our starting. For the starting at X smartphones produced. And what does H signify? Is that the final number of smartphones produced or the change? That's the change. That's our delta X, right? So therefore, what's the final number of smartphones produced?
H plus X.
X plus H. So she took C of X plus H, the cost of making X plus H smartphones, minus the cost of X smartphones, over H. That's right. Yeah. That's it. That's the difference quotient, right? That's exactly, I'm describing exactly the difference quotient for this situation. Okay, now suppose that cost function was negative x squared minus 5,000x. That's actually not the curve it left, but it will do for our example, okay? Okay, so there's our actual cost function that gives us the cost for producing X smartphones. So we want to rewrite the difference quotient using the rule, okay? Using the rule, rewrite the difference quotient. Remember, C gives us a set of instructions on what to do with the input. It gives us a set of instructions what to do with the input. So look at your input and do that with the input. Whatever that input is, follow the instructions that the rule tells you to do to the input. And set up that. All right, let me see your initial step. Show me. out. You're going to subtract all of C of X. This one, you're going to make a mistake here because you need to subtract C of X, the entire C of X. You see? Okay, so that's just this bit, right? It's a good start. But now you got to minus C of X and the whole thing over H. See? Yep, good. What's the first step? We're going to involve that.
I did wrong with this minus this.
Is the top, right? Yeah. So all you've done at the top is just that. Now you have to subtract C of X. That's right for C of X plus H. Oh no, that's not.
Yeah,
That's
basically
not.
wherever you see
Yeah.
X, you got pay attention.
No, so there's actually take the input and square it, and once you square it that much, then take the opposite. And then you're going to subtract what? Times the input. Not 5,000x, 5,000 times the input. Just like you squared the input when you started, then later you're going to take 5,000 times the input. That's what it's. So everywhere you need that everywhere. So what does C of X plus H mean? It means take the input X plus H and apply the rule to the new input X plus H. Right? What this means is, this tells you what to do with the input. Now, what's your new input? X plus H is your new input. So you're going to take that new input and do this to that new input. Everywhere there's an input here now, X plus H is your new input. So you were doing C, you're starting to put expressions in here. No, this is a set of instructions on your input. So you take your input, you follow the instructions, what it tells you to do about the input. Does it help? That was the reason for writing out the instructions. It really helps. Anybody else want me to check? You got it. Yeah. That means square the input, take the result, make the opposite of the result. Doesn't mean square negative x. Yeah, so what you're confused with not similar. This always means square the input first, then take the opposite. Anybody else want me to check? It's good. Anybody else want me to check? Everywhere, yeah. Yeah. Square the input, then minus 5,000 times the input, right? Yes. Here's another way to think of it. That's what that rule, C of X, that's what that rule is saying. Okay, Corey, did you get the first step? Tell me.
X plus H squared minus 5,000. X plus H. And I got that minus.
Okay, let's stop right there. Is that exactly right? Missing one thing.
There's negative that I'm missing.
See that? Yeah. You might, maybe you said it and I didn't hear you. And then what?
And I'm going to subtract that from 1/6 negative X squared minus 5,000X.
Okay,
Over H.
let's stop right there and check and see if that's what you got. Agree? I see some nods. Looks good. So I'm going to use the space over here now to finish this up. Okay, let's just crank it out. See, I know a lot of you have done some work so far, so just compare. This will be negative x squared plus 2xh. Is it big enough in the back? Can you read it in the back? Minus 5,000x minus 5,000h plus x squared, right? Minus a negative. And then here's the key. He put parentheses around that c of x, which is good, because that minus will also distribute to that second term, so it's going to be plus 5,000x. Good so far? Distribute this negative, so negative x squared minus 2xh minus h squared minus 5,000x minus 5,000h good. So, oh, sorry, this is all over h. That's all over h. So is this. Well, at the end, right? Okay, what becomes 0 here? We got a minus x squared and a plus x squared. Anything else? Minus 5,000x plus 5,000x. So what we're left with is negative 2xh minus h squared minus 5,000h all over. Now we can factor out our h. Minus 2x minus h minus 5,000 equals minus 2x minus h. Did I do all the math right? All right, so what does this give us? So if I put in an x is our starting number of smartphones, and h is, what did h mean again? How many additional